Hi, in this video we're going to be looking at the January 2015 Higher Paper 1 question 12. And as you can see, it's a question about simultaneous equations. You're told that quite clearly. Normally when you see two equations like this, you're half expecting that that's what it's going to be. Now, there are two ways that you can solve simultaneous equations. One uses a method where you would multiply one or two of the equations by different factors in order to get numbers equal in the two equations. So for instance, if we multiplied through by 5 on the second equation, we would have 5y plus 5x equals 35, and we could subtract the two equations away to get rid of the y's. That's one method. Now the second method is the method of substitution, and we use that when we don't have a number in front of one of the letters. In this case, you'll see we don't have a number in front of either of the letters, so we could use either of the letters here to rearrange to find out what that letter is equal to. In this case we're going to work with y, but we could have done this problem just as easily with the x, and this method would apply even if you had things like y plus 5x equals whatever, or 3y plus x equals whatever. Whatever letter is on its own without a number, you would rearrange the equation to get it equal to whatever it's equal to on the other side. So in this case we take the x over to the other side and we find that y is equal to 7 minus x. It was plus here, and becomes minus when we bring it over to the other side. So what we can then do is we can substitute that into the first equation. We can substitute the 7 minus x in place of the y, because we've found out that y is equal to 7 minus x. So wherever we see a y in this first equation, we can put in what it's equal to, what we've clearly identified here that the y is equal to. So we put that in, and then from then on it's just simple algebra. So we're going to multiply through the brackets, and we get 5 times 7 plus 5 times minus x. Notice I've put the minus x inside a bracket to show that the minus is quite clearly attached to the x. Then we move on and we get 5 times 7 is 35. 5 times minus x gives minus 5x. And you'll notice we've got a minus 5x and a minus 4x there, so we combine those to get minus 9x. We now have 35 minus 9x equals 8. Bring the 35 over to the other side, it becomes a negative. Now we have 8 minus 35, which gives minus 27. Bring the minus 9 over. Now remember, it is the minus 9, so we need to take the sign with us. And we find that we get minus 27 divided by minus 9 will give 3. Notice when you divide a minus by a minus, you get a positive number. That's one of the rules that you should know very clearly. Moving on, we can now use the original equation that we had, which was y equals 7 minus x, and we can substitute in the value for x that we now know. We now know that x is 3, so we can substitute that into the equation, and 7 minus 3 just gives us 4. So that's our final answer. The problem has been solved. We've found out the value of x and y. X is 3 and y is 4. Interestingly, just to extend this a little bit beyond what's in the question, if we drew graphs of these two equations, they would cross each other. They're straight lines. Both of these are straight lines, and they would cross each other at the coordinates 3, 4. Okay, that's all for this particular video. Thank you for listening.